Let's see another technique today. That's a recursion take not take or pick not pick technique. So first try to understand the problem, and then we'll also utilize this technique and understand this technique. So let's see the problem. So today problem is house robber, and if you try to understand this, we'll find this kind of the numbers here, and we want to calculate the highest number when we when we start from here. You do not have to consider the adjacent value, but you have to consider the next one. So let's go through this problem description. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security system connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. So the problem is, if you want to rob this house 1, then you cannot rob 2. You can rob this 1 and then 3, and then again you cannot rob 1. And if you start from 2, then you can rob 2 and then not 3 but again 1. Then you have to find the max, how much max you can rob, and you have to return that value. So in this problem, if you see here, if you rob 1 and 3, that's a total is 4. And if you start from 2, then 2 and 1, then total will be 3. So the 4 is max, so we are going to return 4 here. So that's a problem. It's a medium level problem, and we are going to use the recursion here, pick and not pick technique. So in a recursion, we know we need the base condition, so we have to find out the base conditions also. So let's write that. So I'm going to write a function like rob house, where I'm passing nums, and then I'm also passing last index. So last index is len nums -1. So I'm starting from the end, so from here I'll go to the beginning. So that's the index 1, so that's the last index. Okay, and whatever is return, I'm going to print that. It has to be returned. Okay, just return this. Well, let's define the function and we write our logic. Func rob house and nums last index is an int and return int. Okay, so first we need exit condition. We know we are going to use the recursion, and in recursion we must need exit condition. So that's the one thing. Second thing is, if you want to calculate the max, then we have to check all the items. So we have to encounter all the item. So we can start here and jump to this place. Then again we can start from here and again jump another next place. So we need this technique. So first write the base or exit condition. So consider if there is a 1 item, so we can just let's consider 1 item just 1. So in that case we are just our result will be 1. So the base condition will be like this: if last index equal to 0, then just return the item nums 0, because if there is a 1 item, then we are going to return just that's item. So that's one base condition, and we know we'll iterate, or we use the recursion, and we'll start from here and then go this place, go this place, go this place, and sometime maybe there's a chance we can go end, because we are jumping from here to here and here to here again. So if there's a -1 index, so if last index equal to -1, so in that case we are going to return just 0. Okay, that's a base condition. And the next thing is we have to call this function. So let's call this function. So call the function, and it's a nums pass and then last index -2. Yeah, so last index is this one. If you want to go here, it's a -1. If you want to go here, it's a -2. So in that way, like, we can jump here, so that's why we need -2. So in that case, like when we jump from here to this place, like first end to skip 1 and come to this place, then in that case consider this number in a result. So that's we can say that's a pick. So I can say num last index, num last index, and I can say that's okay. It's a pick or not pick. You can say pick, take, kind of thing. So from here I consider this item and then again jump to this place. So that's why last index 2. So in that way, this function will keep jumping the item, and we take that item, we consider the item. And the not pick is something like not pick is num is in the case of not pick, we'll just go to we need the recursion, but we do not consider any item there. So like, let's say 0 here, like 0, and then we can use rob house nums last index -1, and then we have to find out what is the max item from this, and that's what we are going to return. So let's say I'll write the function max here, a b int if a greater than b, return a, otherwise return b. So I'll use the function here, aim max pick comma not pick, and return this item. Okay, so this is going to return the max the robber can rob. So let's submit this. Let me connect. Undefined num. What is this? It's a nums. Okay, let's run once again. It's accepted. Let's try to submit. Okay, so we see the time limit exceeded. It's going to take long time, because when we use the recursion, we are calling again and again the same function. So in that way it's going to take more time. So in that case we can use the memoization, where if you already called some of the solution, you can store the solution and we can utilize that solution. So let's use this here. So I'm going in order to store my result, I need a memory here. So what kind of result I'm saying, like, let's say I'm calling this function, like if like, let's say you can start from the last index 1 from here, and again come to the 2 f to this function, then we call this function for one index and return and store the result. So in a recursion, the same function will be called again, and if you find the result, then just return the result. Don't go to the function. So that's why we need the memoization here. So let's use that. So I'm going to create a variable make int, and the length is nums. I can pass this here, dp pass. So dp, and here I can check. First I can store the result. Like I call this function for last index, so in my dp last index, and the result is m, because the m contains the max value. So I can store the result in this dp, and I can check the condition here, like if dp last index, or I can say store some value here like -1, or yeah, I can add the condition here like -1. Then in the beginning, I'll put, I'll initialize that dp with a -1. If it is a -1, then return the result dp last index. So let's initialize this here. So for go to 0 and I less than length of dp I plus plus dp I to -1. Okay, so let's try to run this, and it's going to work this time. Okay, we have to pass dp here too, and this place too. Wrong answer. Why? Let's check once again. So initialization is good. I0 dp I -1, that's good. Last index is equal to 0, then nums 0, that's okay. Done. This one. Last index is not -1. It can be the -1, -2, anything. So it's a less than 0, then return 0. Okay. Again. dp not, so dp not equal to -1, then return the result. Yeah, if it is a -1, then y to return. Yeah. Okay, accepted. Let's submit now. Yeah, that's good. So bit 64%. Yeah, that answer is accepted. Let's see the solution in a Java also. It's the same approach. So in a Java also I created the dp, and I fill the dp with a -1, and I have the last index here, call the rob house with the last index. I'm checking the condition equal to 0, return that nums 0 value. If the last index is less than 0, then return 0. If you find the result in a dp variable, then return that result. Otherwise, we can call this a strategy, pick and not pick a strategy, where we can jump with the index -2, and we can take the current item, last index. So that's a pick, and the not pick it's a normal flow, last index -1, and we'll say the 0. We'll calculate the max. We can store that result and return the result. So that's all for today, and you can also watch another playlist, that's a logic building long video playlist, where I'm also going to explain the flow, about like how either the recursion will happen. So, and that video is going to be a little bit longer, but yeah, if you are good here, that's good. Otherwise you can jump to that playlist, and you can see That's all the flow, recursion flow. That's all for today.